So, hello everyone. Today we are going to continue our journey completing NCERTs of science. So, this is chapter 3 Atoms and Molecules. And Indian philosopher Maharishi Kannad postulated that if we go on dividing matter, that is Padarth, we shall get smaller and smaller particles. Ultimately, a stage will come when we shall come across the smallest particle, beyond which further division will not be possible. He named these particles Parmanu, which is known as atom. Alright. Now, what is law of chemical combination? Two laws of chemical combinations were established after uh, Lavoisier and Joseph L. Proust. Now, law of conservation of mass. What do you mean by that? Let's move forward. Law of conservation of mass state that mass can neither be created nor can be destroyed in a chemical reaction. And what is the law of constant proportion? Ratio of mass of hydrogen to mass of oxygen is always 1 is to 8. It is an example that the ratio of another atom to another atom, the masses of them, will always remain same in a compound. Now, in ammonia, nitrogen and hydrogen are always present in the ratio of 14 is to 3 by mass. So, what does it state? Law of definite proportion. The law was stated by Proust. In a chemical substance, the elements are always present in a definite proportion by mass. Now, John Dalton provided the basic theory about the nature of matter, idea of divisibility of matter, name atoms, and he named it atom. And his theory was based on the law of chemical combination. Dalton atomic theory provided an explanation for the law of conservation of mass and law of definite proportion. This is John Dalton. He was born of England in 1766. Now, Dalton atomic theory. An element, a compound, or a mixture is composed of small particles known as atom. This was his words, and he gave several postulates. Matter is made up of very tiny particles called atom, which participate in chemical reaction. Atoms are indivisible particles which cannot be created nor destroyed in a chemical reaction. Atoms of a given elements are identical in mass and chemical properties. Atoms of different elements have different masses and chemical properties. Atoms combine in ratio of small whole numbers to form the compound. Alright. And relative numbers and kinds of atoms are constant in a given compound. I hope it is understandable as these statements are nothing much to worry about. Alright. And what is an atom? Atom is like a building block of a all matters are atoms. Alright. Atomic radius is measured in nanometers. That is 1 by 10 to the power 9 meters equal to 1 nanometer. That is 1 meter is equal to 10 to the power 9 nanometer. I hope we all remember it correctly. 1 meter is equal to 10 to the power 9 nanometer. And here relative size have been given, though it is not useful. Now, entire world is made up of atom. That is absolutely correct. And name of elements were derived from the name of places where they have been found in the first time. Like copper was taken from Cyprus, and name was taken from a specific color. Gold was taken from English word meaning yellow. Now IUPAC, International Union of Pure and Applied Chemistry, is an international scientific organization which approves name of elements, symbols, and unit. First letter of symbol is always written as capital letter, uppercase, that is, and the second letter is the small letter, lowercase. Now, hydrogen H, aluminum Al, not Al, that is, not both of the letters are in uppercase. Alright. Now, first letter of the name and a letter appears later in the name. Example, chlorine Cl, zinc is Zn. Now, the symbol of iron is Fe. It is a Latin word known as ferrium. Sodium Na was natrium, and potassium is K from kalium. All right. So there are the symbols of some of the elements, and What is atomic mass? Each element has a characteristic atomic mass. Law of constant proportion measures the atomic mass of an element. Sorry, atomic mass of an atom. That is law of constant proportion. Atoms cannot be. Everything is of constant proportion in an element, a mixture, or an compound. Relative atomic masses were detained using the laws of chemical combination and compound forms. All right. Carbon monoxide, that is CO, formed by carbon and oxygen, where when carbon combined with 4 grams of oxygen, that is 3 gram of carbon is combining with 4 gram of oxygen to form carbon monoxide, that is CO, and carbon combines with 4/3 times its mass of oxygen. Now, abbreviated as AMU. Earlier, the atomic mass unit was abbreviated as AMU, but later the IUPSC recommended that instead of using AMU, let's call it mu. That is U. Unified mass, it is equal to the mass of an carbon atom. And carbon and atomic mass of 1 U. Alright, carbon has an atomic mass of 1 U, and oxygen an atomic mass of 1.33 U. I hope we must remember it, it is very useful. Now, the scientists initially took 1 by 16th of mass of an atom of naturally occurred oxygen as a unit. Now, oxygen reacted with large number of elements and formed compounds. This atomic mass unit gives masses of most of the elements as a whole number. Now, carbon 12 isotope was chosen as a standard reference for the measuring of atomic masses. One atomic mass unit is a mass unit equal to the exactly 1/12, 1 by 12, and the mass of atom carbon atom is 12. Now we will discuss about isotopes, isobars in the next chapter, and if possible in this chapter only. All right. Now, here are some atomic masses have been given. Hydrogen is 1, carbon is 12. That is just double of their atomic numbers. All right, nitrogen 14, oxygen 16. And why do we have to remember all those? All these things must be remembered. All right. If you know atomic number, you can easily find out the uh, atomic masses. How does atom exist? The atoms form molecules and ions. All right, and what are molecules? Molecules are a group of two or more atoms that are chemically bonded together, held together by attractive force. And smallest particle of an element or a compound that is capable of independent existence shows all the properties of the substance. Atomic of the atoms of same elements or different elements can join together to form molecules. Now, molecules of elements. Molecules of an element are constituted by same type of atom. That means argon, helium, etc. are made up of only one atom of an element. Now, molecules of oxygen, it consists of two atoms of hydrogen, hence it is known as diatomic molecule. That is O2. Three atom of oxygen until into molecule instead of usual two, we get O3, that is ozone. And the number of atoms constituting molecules is known as atomicity. I hope it is understandable. Now, atomicity of some elements have been given. Some non-metals, and these are argon, helium, oxygen, hydrogen, nitrogen, chlorine, phosphorus, sulfur, and whether they are monoatomic, diatomic, or tetra or polyatomic, it has also been given. It must be remembered. Molecules of same compound: water, ammonia, carbon dioxide. All right, and their ratio by mass have been given. And what are ions? Ions are the compounds composed of metals and non-metals containing charged species. The charged species are known as ions. That means metals and non-metals having charged species, and these charges are known as ions. And single charge atom or group of atoms that have net charge on them. Ions can be negatively or positively charged. Negatively charged ion is known as anion. That is, negative is A, and the positive charge ion is known as cation. So how we can remember it? Cation means, let's take my name, Ayush. Ayush is negative. So you can remember it by remembering that Ayush is negative. Hence, anion, A for Ayush, A for anion, both are negative. Alright, positive. Take cat. Cat is very positive species in the eyes of Egyptian. All right. So cat is positive. Cation is positive. Simple. A group of atoms carrying a charge is known as polyatomic ion. All right. If there are more number of charges, if a group of atoms, that is, there's a group of atoms and carrying a charge, is known as polyatomic. Now, ionic compound, constituent elements, and ratio by mass have been given. Carbon oxide, calcium and oxygen. Magnesium is magnesium. Sulfide, magnesium sulfide is magnesium and sulfur. Sodium chloride is sodium and chlorine, and their ratio by proportion has been given. All right. Now, the combining power or the capacity of an element is known as valency. I hope valency is known. If an element, if an atom can combine with most number of other elements or atoms, then it has high valency than other uh, atoms. The more it can combine with other elements or atoms, the more it has the valency. All right. So here some names and symbols of ions have been given. Sodium is Na plus, potassium is K plus. All right, and nitrate is N3 minus, oxide is O2 minus. All right, ammonium is NH4 plus, hydrogen carbonate is HCO3 minus. All right, so we must remember it correctly. The valencies or the charges on the ion must be balanced. That means whatever, if an compound, if an element or compound is being given, their valencies have to be charged enough. And compound consists of metal and non-metal, and the name of symbol of metals is written first. That means calcium oxide, first metal will be written calcium and later the oxide. In sodium chloride, first Na, then Cl, where oxygen, chlorine, sulfur, and other metals are written on the right, whereas the calcium, sodium, iron, and copper are written on the left. Now, the compound forms by polyatomic ions. The number of ions present in the compound, we usually uses the bracket, telling that the compound inside those brackets, it has a valency of 2. All right, enclosing the formula of ions in the brackets and written the number of ions outside the bracket. That means outside the bracket there are 2 ions. All right. Formula of simple compound. Simplest compound, two different elements are known as binary compounds. Binary means two, like hydrogen chloride, hydrogen sulfide. HCl, H2S. Two elements are there, so they are a binary. And there is also carbon tetrachloride, CCl4, and magnesium chloride, Mg2 plus, and anion is Cl minus, and magnesium chloride is MgCl2, and there is magnesium chloride, two chlorides ion Cl minus 2, so Mg2 plus, uh, and Mg2 plus and Cl minus. Hence, some examples have also been given: L2, Al2O3, aluminum oxide, calcium oxide, CaO, and formula is CaO, but if we balance it out, both Ca2 and O2 have two atoms, two charges, and we can say that they both were cancelled and CaO was used. All right, there are two, both charges are there, O2 minus and Ca2 plus. So both will get cancelled. It will be neutral. All right. Now we use brackets when we use two or more same ions in the formula. All right, and the brackets around OH with subscription 2. Subscript 2 indicates that there are two hydrogen oxide O2 groups uh, joined to one calcium atom. That means CaOH2 is there. That means with Ca, two compounds have been added. Like OH, there are two OH which are combined with Ca. So in order to, we cannot write CaOH. So in order to write it correctly, we have written CaOH whole square. Whole square means 2 in the bottom. Now it is same has been given. Now let's move forward to molecular mass and mole concept. Now, the molecular mass of subject is the sum of atomic masses of the atoms in a molecule of substance. That means if a molecule is being given, so it will have some atoms, and their atoms masses will be added to get the molecular mass. That is, the complete molecular mass can only be obtained if we add the mass of the atoms present in that molecule. And therefore the relative mass of molecule expresses in atomic mass unit, that is U. All right. And formula unit mass, the formula unit of substance is sum of atomic masses of atom in formula unit of a compound. The formula unit mass is calculated in the same manner as we calculate the molar mass. The only difference is that we use formula unit for those substance whose constituent particles are ions. That means sodium chloride, as discussed above, has formula of NaCl. Its formula unit mass can be calculated as 1 into 23, all right, plus, that is Na plus Cl, that is 1 Cl is there and 1 Na is there. So we will multiply its atomic mass into 1 and into 1. If Na2Cl3 would have been there, so we would have multiplied Na, that is 23 by 2 and 35.5 into 3. Understood? This is the formula unit mass, and this is the difference between formula unit mass and the molecular mass. Now, what is mole concept? That is 2H2 plus O2 is equal to 2H2O. Now, what is indicated by that? If we understand the mole concept. Now, in here, two molecules of hydrogen, that is this part, with one molecule of oxygen to form two molecules of water, that is 2H2O. This has been expressed here. Now, 4U of hydrogen molecules combine with 32U of molecules to form 36U of water molecules. Sorry. Same thing. Now, 2H has been there. 2H means 2, and there are two compounds, two molecules of hydrogen. Hence, 2 into 2 is equal to 4 unit of hydrogen molecules, which are combining with O2. O2 means 2 into 16, that is 32 of the molecule to combine 36 unit of water. 36 means 2 into H2 was how much it was earlier. Earlier was 4 plus 32 is equal to 36. So it is understandable, I hope. And the quantity of substance can be characterized by its mass or number of molecules. Understand? The quantity of substance can be characterized by the mass or the number of molecules. The chemical reaction equation indicates directly that the number of atoms or molecules taken part in reaction. More conveniently to refer the quantity of a substance in terms of number of its molecules or atoms rather than their masses. So a new unit mole was introduced. All right, and here it has been given 1 mole of carbon atoms means there is 6.022 into 10 to the power 3 atoms of carbon present there, and it is also known that 1 mole of carbon means 12 gram of carbon atoms. All right, this is molecular mass indicating the, and this is the Avogadro number. Now, 1 mole of hydrogen atom means 6.022 into 10 to the power 23 atoms of hydrogen, and it also means that 1 gram of H atom is also present there. That means one mole of any particular atoms, any atom molecule ion is there. It will be told that 6.022 into 10 to the power 23 number of that particle is available, and it will also be meaning that relatively mass of all those particles in gram. All right, mass will be counted in grams, which will equal to 6.022 into 10 to the power 3 number of particles. That means 1 mole is equal to 6.022 into 10 to the power 23. 1 mole of molecule means 6.022 into 10 to the power 23 numbers of molecules. All right, this is the number of molecules, and it decided the molecular mass of in gram. Now, mole, Avogadro number, and mass. Now, the number of particles, atoms, molecules, or ions present in 1 mole of any substance is fixed with a value of 6.022 into 10 to the power 23. Alright, that means 1 mole of any substance is equal to 6.022 into 10 to the power 23, and it is known as Avogadro number or the Avogadro constant, and it is represented by NO, and it is named after the honor of an Italian scientist known as MDO Avogadro. 1 mole of anything is equal to 6.022 to 10 to the power 23 in number, and that which is equal to, that means if we want to understand it properly, remember the example 1 dozen has 12 number, You all know that, all right? One fortnight is 14 days. So similarly, one mole of anything will be 6.022 into 10 to the 23 in number. Now, mass of one mole of substance is equal to the relative atomic or the molecular mass in gram. All right, one mole of a substance will be equal to the relative atomic and molecular mass in a grams. We will decide in grams, not in AMU or U. All right, atomic mass of an element give us the mass of one atom of elements in atomic mass unit. All right, that means the atomic mass, if we find the atomic mass of any element, it will give us the mass of an atom, one atom of that element in the atomic mass unit U. The molar mass of an atom is known as the gram atomic mass. Here we have seen the formula, atomic mass, the molecular mass, and here it is the gram atomic mass. Means same thing, but we have converted into gram. All right, nothing, no difference is there. One u hydrogen has one atom of hydrogen. 1 gram of hydrogen has 1 mole of atom. That means if 1 u means the atomic molecular mass have been given of 1, it means it has 1 atom of hydrogen, but it also mean it also has 1 gram of hydrogen, and 1 gram of hydrogen has 1 mole of atom. That is, 1 mole is equal to 6.022 into 10 to the power 23 atoms of hydrogen. It is simply understandable. 1 AMU or 1 atomic mass unit or 1 U hydrogen has 1 atom of hydrogen, and 1 gram of hydrogen has 1 mole of atom. That means when we are representing in gram, we will always find mole here, and whenever mole is there, it will be equal to 6.022 into 10 to the 23 atoms of hydrogen. Similarly, for 16 U, oxygen has 1 atom of hydrogen. All right, atom is same because the atoms atomic mass unit has been given 16. So atom will be the same. 1 atom of oxygen will be having 16 U of oxygen, but when we convert it into gram, it will be 16 gram only because there is no difference between the atomic mass unit and the gram atomic mass. Now 16 gram of oxygen will have 1 mole of atom, which will be equal to 6.022 10 to the power 23 atoms of oxygen. That means 16 gram is equal to 6.022 10 to the power 23 atoms of oxygen. Now, if we take 18 gram of water, has one molecule of, similarly means firstly we went through atoms. Now we are going through molecules, and similarly things will be going for the compounds as well. All right. If 18 gram of water has 1 mole molecule of water, similarly that 18 gram of water will also have 6.022 molecules of water. I hope it is understandable. It is quite easy if you understand it very well. Now, 1 mole equal to 6.022 into 10 to the power 23 number, and relatively mass in grams. A molecule is the chemist counting number. All right, a molecule is a chemist counting number, just like we count rupees, 10 rupees, 20 rupees. Similarly, a chemist counts it in Avogadro number, that is 1 mole. 1 mole, how many rupees? How many mole? This is how he counts. And mole was introduced by in 1896 by Wilhelm Oswald. Now, some questions have been given. If you are able to find out, calculate the number of moles for the following: 52 grams of helium. Find moles from the mass, and 12.044 into 10 to the 23 number of helium atoms. Find the moles from the number of particles. That means we have to convert. Now here, the number of moles is n. It is represented as n. The given mass is represented by a smaller m. The molar mass is being represented by bigger m, and the given number of particles is represented by bigger n, and Avogadro number is no. All right. Now atomic mass of helium, hydrogen, helium, that is 2. So if atomic number is 2, so its atomic mass will be 4, just double. So the molecular mass of helium will be 4g. Now here is the formula. The number of moles, if you want to find out, firstly we will given mass, what is the mass of it by the molar mass. All right, we have the molar mass 4 gram, and we have the atomic mass as well. All right. Now, what is the total given mass was given in the question? That is 52 grams have been given in the question. So we will put it in the formula. We will get 5 2 by 4. That means 13. That means In 52 grams of helium, there will be 13 mole of helium present, and hence this 13 mole of helium will give 6.022 into 10 to the power 23 atoms of helium. I hope it is understandable. Now, we know that 1 mole is equal to 6.022 into 10 to the 23. Now the number of moles equal to, we can find number of moles from grams method also, that is the mass method, and in the terms of Avogadro numbers and particles present here. All right, here how many particles have been present? 12.044 helium atoms. All right, and we know the Avogadro number 6.02. We will divide it and number of moles will be found out too. I hope it is understandable again. And here another formula has been given: mass is equal to mass, molar mass into number of moles. Same thing. Just cross multiply this formula, and you will get same thing. All right. Same formula used in different way. Another number of atoms, if you want to find out, given here is something new. If we want to find out about the number of atoms, as we did earlier, the number of moles. So if we found out the number of how many number of atoms are present, so we will give the given mass. The mass have been given the molar mass by finding out what is the molar mass. The given mass. I'm sorry. Uh, where is the question? Yeah, the 46 gram of Na atom number from the mass. Calculate the number of particles in each of the following: 46 gram of Na atoms, number from the mass, and 8 gram of O2 molecule, number of molecules from mass, and thirdly, zero point 0.1 mole of carbon atoms, number of from the given mole. Now, in firstly, the number of atoms we have to find out. So we will give out the given mass by the molar mass into Avogadro number. So the given mass is 46. The molar mass of nitrogen was 23. All right, and Avogadro number is this. We will divide it and we will get 12.04.23 mass. All right, and here is, if you want to find the number of molecules. Wait, let me just highlight it up. All right, so if you want to find out the, all right, if we want to find out the number of molecules, then we will do the same, given mass by molar mass into Avogadro number. So in order to find the number of atoms or the number of molecules, the same formula will be used: the given mass by molar mass into Avogadro number, and after division we will get the answer. And here the number of particles, another formula has been used. The number, let me just save it up. Okay. Now, the number of particles atom, how many particles we have to find? That is the atom. The number of moles of particles, how what are the moles have been given, and we will multiply it into the Avogadro number, and we'll get the system. Now we have almost completed the chapter. Let us go through a revision so that properly we can understand what was the main crux of it. Now. Uh, During a chemical reaction, the sum of masses of the reactant and products remain unchanged, and this is known as the law of conservation of mass. That means mass can neither be created nor can be destroyed. All right, mass will be unchanged always. So this was it, and the elements are always present in a definite proportion by mass, and this is known as law of definite proportion. All right, that means in any other like for example, H2O has been given. Uh, Let me see whether I have. Yeah, if we have H2O, all right. If we have H2O, then its proportion will always be same, all right. And if its proportion is same, then uh, nothing can be get out from that, all right. I hope it is understandable from my side. Yes. Now, if this H2O is there, all right. If this H2O is there, so always remember that the mass, the law of definite proportion means H will always in 2, and O will always be alone. No matter how many articles you take. If I take three H2O molecules, then in the same molecule, H will always have the two. All right, we will have three molecules of H2, and we will also have three molecules of O. All right, so this is what all about it. Uh, I don't have actually the pen, so we will deal with it anyhow. I don't know why I'm doing this, but I hope it is understandable from my side. Anyhow, so let's move forward. And now, a molecule is smaller particles of an element or compound capable of independently existence. All right, that means molecules can stay independent. It has its property. It is the smallest particle, and the cluster of atom that can be created is known as polyatomic. Means number of more ions are present, that is it is polyatomic. And the chemical formula for molecular compound is defined by the valency of an element. That means if it has more valency, the more chemical compounds can be seen. The 2 and 3 will be more. And relative atomic mass on scale to compare the masses of different atoms. Atom of carbon 12 isotope was assigned a relative atomic mass of 12, and the relative mass of other atoms are obtained by comparison with mass of carbon 12. Now the Avogadro constant 6.22 into 6.022 into is defined as the atoms in exact 12 grams of number. That means how Avogadro constant was found, in 12 grams of carbon, we had the 6.022 into the power 23. All right, and we count the grams of other elements with the help of carbon only. So hence, every 1 mole of everything is equal to 6.022 into 23. 1 mole is a atom of substance that contains the same number of particles. Particles can be ions, molecules, formula unit, etc., or atom, anything. And these are the atoms to be exact as 12 gram of carbon 12. Hence, 1 mole is always equal to 6.022 and mass of 1 mole of substance is called its molecular mass. I hope it is completely understandable, and we have discussed really well. And I'll continue this, and you will get both of the videos together. That is, I'm going to teach chapter 4 as well, and then we'll move forward. And Mr. Sinha has given some suggestion that we should also do the maths also, but maths will not be possible. But I will do my best to make you understand by it. All right, by understanding the we will understand the concepts here, no problem. And because solving here is not possible, because I'm teaching in the laptop, so through laptop it is not possible to teach, to practice questions, right? But I can teach you the concept. If you want some problems in understanding the question and statements, I will make you understand properly. So thank you everyone, and Jai Hind. Let's see in the next video.